In this lesson, we're going to look at investments that involve regular payments. Up till now, all of our payments have been in one lump sum, so we've been setting PMT to 0 and we've been setting our payments per year to 1. But now we're going to have some regular payments, and let's see how that affects how we fill out the TVM solver. So it says Darva is saving up for a trip to Australia in 5 years. She plans to work on a student visa while she is there. So she needs only enough money for a return flight and her expenses until she finds a job. She deposits $500 into her savings account at the end of each 6-month period from what she earns as a server. The account earns 3.8% compounded semi-annually. How much money will be in the account at the end of 5 years? How much of this money will be earned in interest? All right, so let's highlight some key information here. Our 5 years, that's our T, and she plans to work on a student visa, and it says that she deposits $500 into her savings account at the end of each 6-month period. So that means that this is a PMT, not a PV. How do I know? Because it says at the end of each 6-month period. That means that our payments per year are now 2. So she's putting in $500 twice a year. So that means here we're going to put our 500, but don't forget to put a negative, right? Because that's money coming out of our pocket. Payments per year 2. Now the account earns 3.8% compounded. So that's I here. And it's compounded semi-annually. That means our C/Y is also 2. Compounding per year. So when we have a payment and we're putting in regular monthly payments, if there's no additional lump sum that we're putting in there, then PV is set to 0. Now if we have a lump sum and then we're adding, then we're going to put a value in PV as well. In this case, that's not the situation. We're solving for our future value, but what am I doing with my N value? My N value is the number of years times my payments per year. So in this case, our years, we've got 5 years, so T is equal to 5, and I actually put that in up top here already. But my payments per year is 2, so we would write this as 5 times 2, or 10. So this is a situation where as soon as we change our PY, our N value isn't going to be times 1 anymore. So now that we have all of this, we can figure out what our future value is. So taking out our graphing calculator and going into apps and finance, get back to our TVM solver, we could put in all of these values. So 5 times 2, 3.8, that says 5, 3.8. PV is 0, that's okay. PMT is my negative 500. Future value is what I'm solving for. Payments per year is 2 and compounding is 2. Solve for our future value, alpha solve, and we get $5,449, and that would be 90 cents there. Okay? So our future value, our value comes out as 5449.896, and we would write that out as $, because this is money, $5,449, and always 2 decimal places, 90 cents. Now the question also asks how much of this money will be earned in interest. So in order to do that, we would have to take our future value and subtract off our principal. So if we do that, our interest would be this value that we just calculated, subtract the initial 500, but we didn't just put $500 in there, we put $500 twice for 5 years. So this would be 500 twice a year for 10 years. So make sure that you're putting all of those values in, and in that case, we're actually depositing $5,000 as our principal, meaning our interest would be $449.90. Now another way of doing that, again, we can go in and use our sum of our interest. So if I go in here, go back to apps, finance, and scroll down, and we've got our interest here, enter, and that's going to go from 1, and in this case you're going to put in the 10, that's your n value, enter, and we'll get that same amount, $449.90. Okay, so you've got two options for figuring out. So we have sum of the interest for figuring out your interest, and that would be from 1 to 10, and you would get the same value. Now remember, this is your n value that you're putting in. Your starting value is 1, and because it's for every payment that you're making. All right, let's try example 2. Example 2 says Adam made a $200 payment at the end of each year into an investment that earned 5% compounded annually. Blake made a single investment at 5% compounded annually. At the end of 5 years, their future values were equal. What was their future values? So we're given lots of information here, but how are we going to use this to figure out what we're solving for? Well, it says here we have a $200 payment at the end of each year. So this isn't one lump sum for the whole term, this is an annual payment. So in this case we're going to use PMT, not PV, even though the annual payment means P/Y is 1. So be careful, because often we have PY being a value other than 1 when we have regular payments, but because we know that this is a payment made at the end of each year, we are putting it in as PMT, not PV. Now, we've got our interest, which is usually easy to identify. Compounded annually, meaning my CY is 1. And that's it for Adam. So for Adam, I would have 5 times 1, because this is 1. My PV is 0. My PMT is 200. And I is 5. Right? Don't forget PMT. I forgot my negative there. That's really important. My compounding is 1, and we're going to find the end. So once we do this, we can find our future value. You can go ahead and do that. I'm not going to punch that in again. You go ahead and do that, and you can see that we would get 1105.126 and so on. Okay? So that means for this question, this is Adam we're figuring out, he earns $1,105.13. By finding the future value for Adam, we're actually also finding the future value for Blake. There's not enough information given in the question to figure out part B if we don't use the information from Adam in order to figure that out. So for B, it says, what principal amount did Blake invest 5 years ago? So we're figuring out PV. Why PV? Because it says Blake made a single investment. Single investment is referring to PV rather than the 200 payments that Adam made. So here we're solving for PV. The number of years stays the same. Because it's a PV, or PY is 1, so it's 5 times 1. The interest is the same, 5. There's no regular payments, right? But we're going to leave that future value. So we've got this 1,105.126 on all these decimal places. Leave all those decimal places in your calculator for FV, for your future value. Don't round it. That way you're going to have a more accurate answer for when you're figuring out PV. Payment is the end, and our compounding is 1. Punching that into your calculator, you'll get a PV value of negative 865.8955, which means that Blake invested $865.90 5 years ago. So sometimes we get questions where we have to use pieces from one part to figure out the pieces of another part. But without having a good understanding of PMT and PV, that wouldn't have been clear in this question. Also, understanding that the future values were the same for both of them allowed us to get enough information to figure out what we needed for Blake. Part C is the last part. It said who earned more interest and why. And that's an interesting question. Does it pay to continually add money to your investment throughout, or should we just put one big lump sum in at the beginning? So if we look at Adam and we figure out his interest, we can just use A minus P because we already got rid of some of Adam's information in our graphing calculator. And then for Blake, the same thing. If I had read this earlier, I could have used that sum of the interest formula from the financial calculator there. So here I would have had for Adam $1,005.13 minus, now remember, we've got 5 years, 1 payment per year, and $200 per each payment. So that would give us an interest of $105.13, where for Blake, that same future value, but just subtracting the single lump sum of $865.90, and he has an interest earned of $239.23. So the difference, if you subtract those, 239.23 minus 105.13, punching that into your calculator, you would get a difference of $134.11. So Blake has earned that much more in interest than Adam. So everything else being the same, we can also see there is a difference in how much interest is earned depending on if you have one lump sum or if you're making regular payments. But that's also determined about how often you're making these payments, if you can afford to make these payments, how much money you have to invest right at the beginning. Okay, so there's lots of variables there. All right, let's take a look at example 3. It says Jeremiah deposits $750 into an investment account at the end of every 3 months. Interest is compounded quarterly, the term is 3 years, and the future value is $10,059.07. What annual rate of interest does Jeremiah's investment earn? So everything that we've done up to now, you have enough tools to figure this out, except now we're figuring out what I is. So how can we figure out the rest of the information that goes into the TVM solver? Well, because we're making regular payments, we've got PMT is $750 and no other money is being invested. Our payments are made at the end of every 3 months, meaning we're making quarterly payments 4 times in a year. Right? Every 3 months means P/Y is 4. 750, that was my PMT. At the end, and this is for 3 years, so that means, oh, and it says quarterly right there. The term is 3 years, and it says the future value is 1,059, not 1,000, 10,059.07. So I'm going to put that in here, 10,059.07. Catching, I forgot a negative in PMT. That's very important, otherwise we'll get an incorrect answer. So 3 years quarterly means that n is going to be 3 times 4. And then this is also compounded. How is this compounded? Compounded quarterly. So we've got a 4 there as well. Okay. Punching all of that into our calculator. Let's see what we get here. So 3 times 4. We're solving for I. PV is 0. Negative 750 for PMT, future value, payments per year is 4, compounding is 4. Now, you'll notice that a lot of times those are the same, but that's not always the case. So just be very careful and cognizant as to what you're putting in for CY and PY. They're not always going to be the same. Okay, so we'll go up to, they're often the same, but not always. Alpha solve, and we get a value of 8.000, so that's 8%. So get 8.0000191. We can conclude that the annual interest lost an N, annual interest rate is 8%. Okay. Example 4. Celia wants to have $300,000 in 20 years so that she can retire. Celia has found a trust account that earns a fixed rate of 10.8% compounded annually. What regular payments must Celia make at the end of each year to meet her goal of $300,000? So $300,000, that would be our, not our PV, but our FV, right? That's our future value. That's her end goal. So I'm going to write that in here. And in 20 years, put that in for N, but that's going to be multiplied by whatever PY is. Now it says Celia has found a trust account that earns a fixed rate of 10.8%, compounded annually. Now it says what regular payments must Celia make at the end of each year, meaning that P/Y is going to be 1, which means we're going to multiply our 20 by 1. Now it says what regular payments means we're solving for PMT, not PV. So PV is going to be 0 and we're solving for PMT. So reading really carefully to see what it is we're being asked to solve for. Now punching all of this into your calculators, you should get an answer for PMT as negative 4,781 with all of these decimal places, 0.08988. We know that this is money, so we can round and say that she needs to pay $4,781.09 per year. B says how much interest will she earn over the 20 years. So again, we can do this one of two ways. We can say that our interest is our future value minus our principal. In this case, that would be that $300,000 minus, now our principal is going to be our payment, which is $4,781.09 times 20 years, and we're going to do one payment per year. If we do that, we get our interest as $204,378.22, which is a large amount of interest to have earned. All right, last question, example 5. Oh, and for B, if you wanted to use your sum of your interest formula, you can use that as well if you wanted to do that right in your TVM solver. Okay, last example for today's lesson is example 5. It says, on Luis's 20th birthday, he started making regular $1,000 payments into an investment account at the end of every 6 months. He wants to save for a down payment on a home. His investment earns 3.5% compounded semi-annually. At what age will he have more than $18,000? All right, so we're solving for time. Even though n isn't time, n's going to help us solve for time because we know that n is time times our payments per year. So we're going to use that to solve for our t. Now, we know that he's investing at 3.5%. We know that he's investing in regular 6-month payments. So PV is 0, PMT is negative 1,000. And because it's every 6 months, his payments per year is going to be 2. He wants $18,000. And it says that it's compounded semi-annual, so C/Y is 2 as well. Putting all of this in our calculator, we get an n value of 15.78433 and so on. So what does that value actually mean? This means that the number of payments that needs to be made is 16, right? 16 regular 6-month payments. So 16 payments at 2 payments per year if we do that, 16 divided by 2, we would get our 8 years. Okay? So the question's asking, at what age will he be? So it'll be 8 years later. So if Louis is 20, then he'll be 28. So 20 plus those 8 years to give us 28 years old. It's important to read, not odd, old. So it's important to read the questions carefully. So we're solving for time, not solving for number of payments, because this n value gives us our number of payments. Using the number of payments and the payments per year, because there's 2 payments per year, that's our p/y, and this is our n. We can figure out the number of years, so that's our time in years. And then using that time in years and adding it to his current age, we can find how old he'll be when he'll have the amount that he needs for his down payment. That's it for today's lesson. Just keep in mind payment, PMT versus PV, right? Those are quite different in how we use those calculations, and make sure you're reading carefully to see what our keywords are and what we're trying to solve for. Thanks for joining me in today's lesson.